Hello, welcome back. Terry again at Real World Boating. Today I got that battery from one of the previous videos, the black lithium-ion battery. I'm going to hook it up to a solar panel with a Bluetooth charge controller. It's a Victron Blue Solar charge controller. This one does require a dongle that you plug in here. So I had to purchase the dongle separately for this. You don't have to use them, but I did want to have the dongle. And I also got the Victron battery Smart Sense. It is Bluetooth as well, and this will connect to the charge controller. And the great thing about this is it has a temperature sensor. This battery does not have a temperature sensor. And so because this is a boat and potentially freezing temperatures, I would like to have the shut off so it doesn't damage the lithium battery, because they can be damaged if they charge them. I've heard numbers from minus 27 degrees Fahrenheit to minus 25 degrees Fahrenheit. But when you get 5 degrees Fahrenheit below freezing or so, you need to really watch the charging of these, because it can damage it, the cells in it. So I wanted to get the temperature sensor for this. They're like I think I got this for like $30 or something like that. The Victron Charge MPPTs, the charge controllers, the solar charge controllers, are a little expensive. Actually, they're probably one of the best ones, if not the best one on the market out there, but they can be fairly expensive. I believe this Blue Solar charge controller, it is MPPT 75/10, and so that's 75 volts charging, 10 volts discharging. It does have battery, the positive and negative of the battery connections, and I have that already connected up here from the battery as well. The PV, the solar panel, the photovoltaic PV cell, and so that is on there, the negative and the positive as well. And then the load, and I'm going to run a little compressor with a cold plate. It's actually a Norcold compressor, an old one that I've had that I'm planning on in future video to make an ice box. So I wanted to do an actual load test on this with the Bluetooth controller. I'll show the app in a little bit, and it should tell me how many. I've tested it before. It should be about 4 amps, give or take an amp, between 3 and 6 for sure, or 3 and 5 for sure. But it should be around 4 amps running this this little compressor with the cold plate there. So we'll see how that goes. And then a couple things I wanted to do first. First, I have the wires from the actual photovoltaic cell. I wanted to show that you put an actual meter on the positive and negative. So typically, this is a 50 amp monocrystalline solar panel, or 50 watt, sorry, 50 watt, 31.4, I don't know if you can see that, 31.4 volts out of that panel. I'm doing this today because it is a nice sunny day here on Orcas Island. And again, you're on the bow of laissez-faire. I wanted to do this outside for the sun, for the solar panel. So, and so there's that. Then, okay, the solar panel to connect to the charge controller here, the MPPT. It's pretty straightforward. Negative to the negative of the PV. And then the positive to the positive side of the PV. So again, got everything hooked up. My dongle, of course, which is just sends the Bluetooth signal and collects the data from the MPPT, and the SmartSense, the battery SmartSense, which takes the temperature, and also it does the voltage as well, but the voltage is also taken because the MPPT is connected directly to the battery. So actually it's kind of redundant there to do it this way, but I did want to have this connected to this because of the temperature sensor specifically. I wanted to make sure that that was connected to this battery. So I got the app pulled up here, and so I'll come over to the camera and show you some good screenshots of this to show you the app itself. Looks like I'm getting about 31 volts, 30.97, and it's bouncing around just a little bit from the 50-watt solar panel. Like I said, it's monocrystalline solar panel, and I got it angled a little bit, so it's getting some pretty good sun there. And the voltage going into the battery is actually 15.97. I'm probably going to reduce that a little bit on here because I really want the top voltage for charging to be about 13 on this. I think it's rated, when I put it fully charged up on this lithium-ion battery specifically, it's like 12.7, 12.8, and so I don't really want to put too much voltage in it. You could damage the cells if you overcharge them. So, and it's all things you can change on the Victron app. So I'll come up closer and show you that, and then we'll turn on the compressor here shortly. I got it all hooked up. Of course, the load side. All I have to do is touch these two leads together. This would be your temperature probe that you would have inside your refrigeration itself. Of course, the cold plate would be inside your refrigeration boxes also. Like I said, it's a Norcold compressor, and then an isotherm cold plate that I have together. I really like these isotherm cold plates. They're thick and heavy, easy to scrape off. It's stainless steel instead of aluminum. I like the fact that it's a stronger, more durable material. If you do have a freezer type situation, if you want to scrape off the ice, the stainless steel is much more durable than the aluminum of scraping up the ice if you have a freezer type situation. Of course, refrigeration, you don't have that. You do have a lot of condensation though, so definitely having a drip hole, a drain in the bottom of your ice box if you're doing that, and it's something for future videos. Plan on building an ice box, putting this system in it. And so I wanted to check the charge and how much current and current that it's taken, and it should be around 4 amps. I have checked it before. So you can see the voltage. Got a little glare here. Try to block that with my hand here. Get the 13.97 volts. No current is going out, obviously. Do got the voltage at 15.97. I do want to change that, and I will here. And then the battery state is equalizing because it's charging. And we'll go ahead and turn on the load here so you can see all that history. I just hooked it up, so essentially no history because we did just hook it up. And then you have trends as well. Sorry, history and then trends. But the status is pretty good. And then I can go into settings and change the setting of, I can change the load output, different algorithms they have, and then the battery itself. I can change to 24, but it is a 12 volt battery. Max charge current 10 amps, of course, and Let's go ahead and change that equalization voltage there. I don't know if you saw that. The equalization voltage right there, which is 15.80. So I'm going to go ahead and bring that down a bunch to about 13 on this particular battery. So hopefully you can see that scrolling down. It takes forever. Wow. 14. Go ahead and bring that down all the way to 13. Even. Click OK on that. So that should update. So now you can see the equalization voltage has been added. The float voltage. Absorption. Bring that down too. So this is the float voltage. Bringing that down also. Oh. Go ahead and do the float voltage to the about 13 or 12.6 on this particular battery. Click OK on that, so you can see that updated as well. And then the float voltage, go ahead and change that float voltage down to, let's see, 12.9. Click OK on that. All right. So I've just adjusted the parameters, so easy peasy. Go ahead and go back to the settings. Go to the battery cell. Here we go to the status again. Still got that 13.1 or 31, right around 31 volts. And no current, and the voltage. Now you can see it's 13 for the battery SID. I did change those parameters, so it's been updated, so it's doing those new adjustments that I just did. So I will go to and turn on the load, and we'll look at the current right here, as you can see, which is 0.0 amps. That should go to about 4-ish. Give or take, so we'll see how that goes. Alright, so now the compressor is running. And those parameters did change. You can see the current is minus 3.5, 3.8, 3.9. So like I said, right around 4 for the current there. And notice the upper voltage there, which was around 31, did do a voltage drop as well because we have a load coming out of that. And so that's interesting to see. That's good to see. So everything's operating normal. And you do have, we're getting 10 watts out of the solar. It is getting in the afternoon, and so the angle's getting off. And of course, even though it is a 50 watt panel, you don't get 50 watts out of them, generally speaking. So, so that voltage coming in, the battery voltage is actually below 12 now, 11.53. And that's pretty common to see a voltage drop when you do have a load going on. And so we should be able to go to the history. And then the trend. So you can see that trend there. The fluctuation of the voltage and the solar. The solar is the red graph, and the solar voltage coming in is the blue graph on the same, you know, plotted on the same graph, of course, but the different lines there. And so it just to jump up and down quite a bit, but pretty good information on that. So let's go back. Oops. It's asking me if I want to change the pin. I'm just keeping it the stock right now, which is 6 zeros actually. 1, 2, 3, 4, 5, 6 zeros on that for the factory setting. And it's actually on the dongle itself. There's a little white button, so you have to press and hold that white button for 5 seconds, and then there's 2 little LEDs on the dongle, and they'll both flash. Normally it's just the one blue LED, I think it's blue, on that dongle that will be lit up. And so they'll flash twice, I believe, really fast, and then it'll reset that to 00. So if you forget your pin and you have access to the dongle, you can always press that and reset that to 6 zeros for the pin to get into that app to pair it with your smartphone. So again, real quick, sorry I'm wavering it around and not very clear. You can see all these parameters here. Alright, I just wanted to get some real clear pictures of this app here, this Victron app. And so you can see the solar coming in is 4 or 5 watts, somewhere in there. The voltage coming in from the solar panel is around 22, 23. So do note that it did change from about 31, give or take, to 24, and that's because the compressor's running. And now you can see the current, the negative 4.2, 4.1 amps there. That is the compressor running, so that is negative because it's not going in. The current, which is positive, which is 0.3 amps, is the current coming in from the solar panel there to keep that charged. And of course the voltage did drop, which is pretty common for a battery. When you hook up a load, you will have an initial voltage drop when you do a load. So it was I don't know if you remember before, it was up to about 13 or so, 15 at first, when it was all coming into the from the solar panel there. And that was, a lot of that was just the solar panel had the charge up, and then I adjusted it down with the parameters on the app itself to tell the MPPT, the charge controller, to reduce the amount for that particular battery, because I didn't want to overcharge that battery. So the current 4.6 amp. And so yeah, I'll go back to I can do this. I can go back to settings here at the top. And these are the things that I adjusted before. The battery. And these absorption voltage, the float voltage, and equalization voltage, you can just adjust those if you just tap on them. And you can just do up or down and then click OK for all those voltages. So pretty easy to change in this Victron app. Pretty straightforward. That way you can protect your battery, protect your investment, because the lithium batteries, that black one, was on the order of about $500. So pretty expensive battery to burn out because you're charging it in too cold a temperature. That's the battery and the solar running refrigeration compressor. And so I hope you liked the video, and we'll see you next time.